Welcome to this video, and in today's video we're going to study Bayes' rule. Okay, so we have studied the rule of total probability in a previous video. First of all, let's revise the rule of total probability. Okay, so the rule of total probability, total probability. We have studied this in depth, okay, in a previous video. So if you want to learn more about this in depth, then watch my previous video. Okay, so what is the rule of total probability? So the rule of total probability says, okay, first of all, let's start with just two events. Okay, so if you have two events, E1 and E2, E1 and E2 are two events here, and there is an event which is B, and this is both in E1, some portion of this is in E1 and some portion of B is in E2, and here E1 and E2 are mutually exclusive, then what we can do is we can write probability of B, okay, probability of B is equal to what? Probability of this portion, which is going to be E1 intersection B plus probability of E2 intersection B. Does that make sense till here? Okay, so actually it should make sense because I have taught all of this in the previous video. Okay, so we can extend this further as probability of E1 times probability of B given E1 plus probability of E2 times probability of B given E2. Okay, so do you remember that now? This? Okay, so you can remember this. This is pretty vividly. That probability of B is what? Probability of E1 times the conditional probability of B given E1. Okay, so if you want to write this thing as probability of B times probability of E1 given B, then you, can't do that. Why you can't do that? Because you do not know what the probability of B is. In another order, if you want to write this thing, probability of B times probability of E1 given B. Does that make sense? If you want to write like that, then it's not possible because we don't know what probability of B is, because we are figuring this out. Okay, but that algebra will also be correct. Okay, but this is the rule of total probability. That was a little revision for the rule of total probability. Okay, so this was for two events, so we can generalize it for as many events as possible, and those events are going to be mutually exclusive. Okay, so let's say we have k many events. Okay, so there are k many events there. Let's suppose now. Okay, so let's suppose that there are. So the general formula, the general rule, general rule. So what is the general rule? So if you want to generalize it, then let's say there are k many mutually exclusive events. Okay, so there are k many mutually exclusive events. So the marker is not working that well. Okay, so if there are k many mutually exclusive events, and there is B which lies in all of those k events. Okay, so some portion of B lies in all of those k many events. So in terms of Venn diagram, what I mean is this. Let's say that E1, E2 till EK, and the B lies in all of them. Like some portion of B lies in all of them. Then what you can write probability of B. Write probability of B as probability of E1 times probability of B given E1 plus probability of E2 times probability of B given E2. Okay, plus this will be plus all the way to probability of EK times probability of B given EK, because there are k many events. Okay, in summation in summation definition, what it would look like is this: probability of B is going to be equal to summation I is equal to 1 till k probability of EI times probability of B given EI. Okay, so it doesn't, there is no space here, so I'm going to write this. Okay, so it doesn't accommodate in that much space. Okay, so in summation notation, what it look like is this: probability of B is going to be equal to probability of, okay, summation I is equal to 0 till k probability of EI, okay, times probability of B given EI. Okay, this is how it look like in summation notation. So this is what the general rule of total probability is. Okay, so how many minutes has been of the video? 4 or 5 minutes? Okay,
6.
okay. Oh, so for 6 minutes actually it was just a revision of what we have learned in the previous video, and I guess this much of revision might be pretty, I mean, it might remind everything. Okay, so it's just like everything from scratch. Okay, so this is the rule of general probability. Now let's talk about the Bayes rule. So what the Bayes rule is, okay, or Bayes theorem it is also called. Okay, or let's call it Bayes theorem. Bayes theorem. So what the Bayes theorem says? So the Bayes theorem says, first of all, it is just the modification of the conditional probability. Okay, so let's say again there are k many mutually exclusive events. Okay, there are k many mutually exclusive events. Okay, there are k many mutually exclusive events, and there is a event B, okay, such that some portion of B lies in all of those k events. So if there is an event B such that some portion of B lies in all those k many events. Does that make sense what I'm saying? This is the same thing that we have done in total probability, okay? And we're going to figure out the probability of, let's say, one of those k events, okay? Probability of, let's say, EJ given B. We're going to figure out this conditional probability. So what does that mean? First of all, it means there are k many events, and of all those k many events, okay, so in terms of Venn diagram it might look like this. There are k many events, E1, E2 till EK, okay, till EK, starting from E1 till EK there are k many events, and B is there, and you're gonna figure out, let's say, the probability of this event, probability of any of those k many events, EJ, okay, so it's EJ means any of those k many events, given B, given that B occurs, then what the probability of that will be. This is what it means, what the probability of that going to be. Probability of EJ given B. Then you already know this is going to be probability of EJ intersection B divided by probability of B. Don't you know this thing? We have discussed about this multiple times in our video. Okay, this is a conditional probability rule, the simple conditional probability. Okay, plain simple conditional probability that we have discussed. Let's modify this further. Okay, so let's modify this further. Video being recorded? Okay, so pay attention. So if you modify it, I can write this thing as probability of EJ, okay, times probability of B given EJ. Cannot write like this. Okay, of course I can write like this. Okay, probability of EJ times probability of B given EJ. Okay, yeah, and divided by the probability of B. Okay, so it is probability of EJ. Why you have written like this? Probability of EJ times probability of B given EJ. Let's say that this thing is known. Probability of B given EJ is known. This thing is not known. Probability of EJ given B is not known, but the probability of B given EJ is known. Okay, it means, let's say EJ is one of those from K events. Let's say this is the EJ, this is the EJ. Okay, so if EJ occurs, the probability of B occurring is known. Probability of B occurring if EJ occurs is known, and you're going to figure out the probability of EJ given B occurs. So B occurs and probability of that specific EJ. Okay, then you can write the numerator like this, and using the total probability rule, we can write probability of B as what? Probability of one of those. Okay, so from summation, I'm going to use the summation, the summation sign. Okay, J is equal to 1 till K probability of EJ times probability of B given EJ. Cannot write like this. What we are doing here. It's the same for probability rule. Probability of EJ times probability of B given EJ, because probability of B is not known, but probability of B given EJ is known. Okay, from J is equal to 1 till K. Okay, so J might confuse you. So let me start I here. I, because this J and this J might confuse you. This J is not changing. Let's write I. Okay, let's write I here. Okay, so there's nothing. So this J is for what? Any specific J, any of those K events. Huh? Let's say probability of E1 given B, or maybe E5 given B. Okay, so if those, that J is a constant, but here this I is a variable, is changing. I is equal to 1, then 2 till K. Okay, so does that make sense? Now this is what the Bayes theorem is. Now does the Bayes theorem make sense? Okay, so let me repeat again what the Bayes theorem again says. Probability of EJ, okay, is EJ given B is probability of EJ times probability of B given EJ divided by probability of EJ times probability of B, EI times probability of B given EI, and I going from 1 to K. Okay, if you have, let's say, only two mutually exclusive events, and those mutually exclusive events are, let's name it E1 and E2. Okay, why I'm giving you the example of only two? Because now you get, the feeling of this more intuitively. Does that make sense? You understand more intuitively if I have only two events. So two mutually exclusive events are there. You only need two, and you're gonna figure out the probability of, let's say, E2 occurring given B occurs. The conditional probability. And what is that going to be equal to? It is going to be equal to probability of E2 intersection B divided by probability of, tell me? B. Simple. And now, what is this thing going to be equal to? It's going to be equal to probability of E2 times probability of B given E2 divided by probability of E1 times B, probability of B given E1 plus, I guess actually I don't have a space to write. Okay. So anyhow, let's accommodate it here. Probability of E2 times probability of B given E2. Does it make sense? So Bayes theorem is a little bit more complex. Probability of E2 times probability of B given E2 is same multiplication rule it is. Okay. yeah, it's the same multiplication rule. Okay, so let's pay attention here. So if E1 and E2 are mutually exclusive events, okay, and then what probability of E2 given B will be, okay, then it's a simple thing, this thing, okay. But if you expand it out or go further than this, then it is confusing, okay. It is confusing both on the numerator and also on the denominator, okay. So let's talk about the numerator first. So probability of E2 intersection B, okay. So the confusion or the more confusing part of this is that this can be written using multiplication rule in two ways, okay. So the first way is probability of E2 times probability of B given E2, okay. And the second way to write this thing is probability of B times probability of E2 given B, okay. E2 given B, both are correct, okay. But the question is which one to write here, okay, which one to write here. Then the obvious thing is that we cannot write this thing. Why? Because probability of E2 given B is unknown. Probability of E2 given B is unknown. This is what we have to figure out. That's why we exclude this thing. I'm going to write this on the numerator, okay. Probability of E2 times probability of B given E2. Easy. Now divide by the denominator part is also confusing, but it is the same what? Total probability rule, okay. So just do the total probability rule, okay. So now let's expand the denominator. So I can directly write this because I have taught the total probability rule, but still I'm going to revise it a little. Why? Because students tend to confuse this a lot, okay. That's why I'm revising it as many times as I need, okay. So E1 and E2 are two mutually exclusive events, and B is here, lying in both E1 and E2, okay. Then what will be probability of B? Probability of B will be probability of B intersection E1, okay, plus probability of B intersection E2. So in words, if you interpret this, then what is probability of B? Probability of B is the probability of B and as well as E1 happening plus probability of B and E2 happening. This is what probability of B is. So basically what probability of B is? Probability of B is that E1 happens and B happens plus E2 happens and B happens. That's what it is. Does that make sense? Okay. And now if you expand this thing further, then this is going to be probability of E2 times probability of B given E2 divided by what the denominator will be now. It will be probability of, we can't write this as probability of B times probability of E1 given B because probability of B is not known. Does that make sense? So you have to go from this. Probability of E1 times probability of B given E1. And plus probability of E2 times probability of B given E2. Okay, this is it. So this is the weighted probability of E1 and the weighted probability of E2 and adding them up. Okay. Okay, so this is what the base theorem is. And if you don't want to complicate this too much or don't want to write in too much space, then you can reduce this as what? Directly use the total probability rule. That probability of B is probability of E1 times probability of B given E1 plus probability of E2 times probability of B given E2. This is the total probability rule for two events being mutually exclusive and B being in both E1 and E2. The general formula, we know what the general formula is. Okay, I wrote this down previously. Okay, but you actually need to have in your mind for two mutually exclusive events. Okay, Why? Because the general is, it follows from this. Okay. Now let's do a numerical example to have more command over the Bayes theorem. Okay, to understand it more efficiently. Let's do an example. Okay. So I have an example written. I have written it on the paper. Okay. So the example. Okay. So marker doesn't work. Okay. So the example is, let's say, probability of having lung disease is given. The probability of having lung disease is 7%. Pay attention. So the probability of having lung disease is 7%. This is known as prior probability. Prior probability. This is known as what? Prior probability. Why is known as prior probability? You know it now. The probability of having lung disease initially is 7%, and the probability of, okay, so among people who have lung disease, smokers are 90%. Pay attention. So among the people who have lung disease, those people who are smokers are 90%. Okay, it means those people who are not smokers and still they have lung disease is what? 10%. Okay, so when in the group of people having lung disease and who are not, smokers, okay, is 10%, and in the group having lung disease and they are smokers is 90%. Does that make sense? Okay. And the next thing is given is we have to nothing is given, so you have to find out what is the probability of having lung disease given that it's a smoker. Okay, and this is known as the posterior probability. Posterior probability. Probability. Okay, so why is known as posterior and one is known as prior probability? So this is initially the probability of having lung disease. It means in the population, in the total population, how much percentage of people have lung disease? Then 7% have lung disease. This is what it means. This is the prior probability. Okay, it means any random person, okay, of any random person, of that person having lung disease is just 7%. Okay, or 0.07. Does it make sense what I'm saying? So any random person of them having lung disease is what? Just 7%. But we have to figure out what is the probability of that person having lung disease if that person smokes, if that person is a smoker. So this is your posterior probability. It means the probability will change. Okay, for one person it might be who's not smoking, for them it is just 7%. But for another person who's a smoker, then the probability of having lung disease is higher. Okay, so this is your posterior probability. It means your initial perspective was this. You want to change your perspective. You want to change your perception. You want to change. Initially you think that the probability of having lung disease is 7%, and now you want to change your perspective. What the probability of having lung disease will be given the person smokes. Okay, or that person is a smoker. So you are changing your perspective, or yeah. Okay, this is what you're doing. Okay. For example, let's say there is a person in a cave, and for many years the person is in the cave is what seeing dark. Okay, there is pay attention, there is dark, and one day he comes out of the cave. Okay, and he says he sees the sun and says, is this some kind of weird thing? Is this a quirk happening? A weird thing? He doesn't know. He says, he has the belief that most probably it might be a weird thing. Okay, so he had the initial belief that most probably it might be a weird thing, but he sees the sun rising daily, then he becomes more confident that this is what? Normal. Does that make sense? It's not something weird. Okay? So his perception has changed. This is what Bayes' theorem is. It changes your perception. Okay, so let's find out what the probability of L given S will be. This is going to be equal to what? Pay attention. Probability of L intersection S divided by probability of S. And you can further write this as what? Pay attention. Okay, this thing. And you can further write this thing as what? Probability of L times probability of S given L. Okay, we don't want to write this as probability of S times probability of L given S, because L given S is not known. Okay, so this will be this. First of all, what it means? It means your initial probability, okay, or the prior probability of having lung disease times probability of being smoker given that it has lung disease. Okay, given that it has lung disease. Okay, this thing. And now let's expand probability of S. So probability of S will be what? This will be probability of S given L times probability of L plus probability of S complement given L times probability of L. So did it make sense, this thing? So probability of S is going to be what? And probability of S is going to be what? So there are two groups, two mutually exclusive events. People who smoke and people who don't smoke. I'm sorry, what I'm saying. People who have lung disease and people who don't have lung disease. And you're going to find an probability of S. Okay? It means smoking. Probability of smokers. What is that going to be equal to? That's going to be equal to this plus this. And this is the same thing as L intersection S, and L intersection S is S given L times L plus, or in other words you can say probability of the weighted average, the weighted probability of having lung disease and the weighted probability of not having lung disease. Okay? So I've written it incorrect. Probability of S given L complement. Okay, times probability of L complement. Okay, so initially it was incorrect. Okay, it is going to be this. So probability of S will be what? Weighted probability of L, weighted probability of L. So weighted probability of L shrink to this size plus weighted probability of L complement. So that L complement shrink to this size. That is going to be your probability of S. Okay. So if you compute it, it's going to be what? Probability of L is 7%, so 0.07 times probability of S given L is 90%, so 0.9 divided by probability of S given L is 90%. Okay, so 0.9 times probability of L is 7%, so 0.07 plus probability of S given L complement. Okay. So probability of S given L complement will be what? Okay, so it might be confusing for some people after this step because I've missed one data here. Okay, so we don't need this thing. So what I've missed here? So one figure I've missed. People who do not have lung disease. People who don't have lung disease, how many of them smoke? Okay, so it's 25.3. 25.3%. Okay. People who don't have lung disease, 25.3% is smoke. Okay, so it's 2. Okay, so plus probability of S given L complement. This is going to be 0.253 times probability of L complement. So what is probability of L complement? 93. Okay, so 0.93. 0.93. So 93%. Okay. Now, if you compute this, what is that going to be equal to? Just do it in calculator. Okay, so I just checked it in calculator. Okay, so if we compute this, it is going to be equal to approximately 0.21. 211. Okay, is that this? Yeah, approximately. So approximately 0.211. Okay, it means 21.1% chance that they have lung disease if they smoke. Okay, so now let's analyze it a little more further. Okay, so the probability of having lung disease if it smokes or if the person smokes is 21.1%. Okay, so from 7% it has gone up to 21.1%. Okay, so initially it was this and now it is this. The posterior probability is this. Okay, now you're like, okay, to answer this question, how do I know what information do I have to know? Okay, to answer this question, the question is probability of having lung disease if the person smokes. Okay, so the question might be to figure out this, what other things do I need to know? Okay, how do you figure that out? Okay, so it is simple. You're going to figure out the probability of having lung disease given the person smokes. Okay, okay, then go and find information about smokers. Okay, find information about smokers. What information? Find people who have lung disease. How many of them are smokers, and people who don't have lung disease, how many of them are smokers? Okay, so you're finding information about smokers in both the groups, having lung disease and not having lung disease. Okay, and the next question might be, how do you know? You have to find about smokers in this group, lung disease and not having lung disease. It is simple, because you want to find out the probability of having lung disease. Okay, given the person smokes. Okay, then you have to find figure out this information first. Probability of the information about smokers. Okay, in both the groups. In group 1, which is people who have lung disease, and group 2, people who do not have lung disease. Then you can figure out the answer to the question you want. Okay, so this was it in today's video for Bayes' theorem, and I hope that this video helped you.